So, okay, so from last class, we tried to evaluate sanitary inspection, which is one of the first steps in solving community issues with water and environmental problems. So it's kind of complex because this methodology which I try to use, I've actually understood that we study a lot of stuff in school and we have some kind of practice which is sometimes not directly applied to community. So this is why this methodology is kind of in a kind of way, maybe you noticed about it, but it's direct to the point and solving some issues directly. So the first step to start solving community water problems or environmental problems is by knowing how to carry out first the sanitary inspection, and for the other course of water quality, which we are already done with it. So to understand the concept behind pathogens and how we get infected, the F diagram for disease, which we studied, and these are all what you need to directly apply your knowledge to your community, which is practical. So it is not much of theory and it's direct to the point. So another aspect which we'll be talking about today, it's water quality, which is the section B for the course environmental field techniques and analysis of water. So the first thing you have to understand about water sampling is that it comes in because when you've done your sanitary inspection, you cannot actually predict or you cannot tell if this particular water source is contaminated or not. So you probably need to do your research further. And that is why I'm going to teach you guys how to carry out water sampling, to collect sample of water for analysis, that you can take this to the laboratory for testing, because this is a required skill which is needed. Many people, you don't know how, maybe sometimes you study and you don't know how to collect sample, and you don't know how to prepare your sample and how to prepare it and how to transport it. This is very important as an environmental officer or agent and the community health promotion agent. You must know these things because it's very important. So now we have to move further. Now we have here, I think I did not forget something, the 10 rules for collecting water samples. Now, probably water sampling is complicated. It's not just something you can just do without you learning how to do it. So the first rule says you use sample container only for water samples and never for the storage of chemicals or other liquids, which means that practically if you want to collect your samples, you must be able to understand which kind of sampling containers you can use. And we'll talk about this. We have plastic and bottles, which you can use for collecting your water sample. So you must make sure that this container which you're going to collect your sample is not having some chemicals already inside, which might also affect the results in the laboratory. Second point is use sample container for microbiological testing only for that purpose, which means that if you're going to be doing testing, like I said, we have different kinds of tests to conduct in the laboratory. Physical, we have chemical, and we have also microbiological analysis. So these different kinds of analysis require different kinds of sampling containers. So you don't have to mix a sampling container used for maybe physical testing or chemical testing with that of microbiological testing, because you have to collect separate water samples for different tests. Sometimes it works like that, but there are some exceptions which we'll talk about. Okay, so we said use sterilized sampling containers for microbiological testing, sample containers for chemical. Yeah, I said that already. The fourth point, level the container before sampling. Yeah, so this is a key point. Now we all know, because we are going to see this point and how we are going to label our sample containers, how we have to follow the procedure. Labeling sampling containers, we must be able to understand that before carrying our sample, taking our samples, we must make sure we have a sample ID. This is why you have to label these sample containers. So when you take it to the laboratory, it will be easy while you're conducting your test. You can actually identify that this particular sample came from this particular source in this community, and this was the time that it was taken. So this is why we conduct this aspect of the practice by labeling sample containers. So it is more important that you understand that this aspect is complicated, and if you don't actually follow these procedures carefully, then you're going to have some issues with your results. So we talk about wash and or disinfect. Please, I want somebody to turn off his mic, and probably if you have questions, you can put it on. Okay, thank you. And we said the fifth point, wash or disinfect your hands before opening the sample container, which you all know that if you want to do something sterile, you must be able to have clean hands and the rest. The sixth point, do not touch the inside of the sample container or cap with your fingers. Yeah, it's very easy, you understand. 7th point, do not rinse the sample container since it is sterile. This is actually for microbiological testing containers. Okay, so we have this other point. Keep the sample container cap open. You understand these ones. We said never use bleach, disinfectant. Okay, but you're going to read those when we share the slides. Okay, type of water sampling containers. We have two types, like I earlier said. We have glass or plastic containers. So these are the two main types you can actually find to be able to carry out your water sampling. So for plastic bottles, which we need to collect, some of these bottles are found available with already some graduations, maybe in meals, maybe some are in up to 500 meals, some are up to 1,000 meals, which are already, they already have this calibration in these containers. And these plastic containers usually are more of heat resistance. So it's preferable, and they use it in the laboratory, while we also have bottles. Now we also have the top one, which is disposable, which is just like plastic bags that you can see once you collect your sample from it, and you take to the lab. Once you have done your analysis with the water sample, you dispose of these sampling containers, which is so. Okay, so we have here, I think there's a question, or I don't know. I don't know if someone is facing the same problem. Talked about network is bad. Sorry. Okay, so now we want to talk about how to clean and sterilize our sample containers. We all know that before we are going in to carry out our water samples, we need to be able to have a clean containers, like I said, either plastic or bottle containers, which we'll use. But before we do this, we must be able to know how to prepare our sample containers. This is how we can be able to get ourselves an accurate result at the end. Because if your sample containers are not clean, you're going to have some kind of false results, which are not true. So you have to prepare them to go. So the first thing is that you must be able to wash these containers with soap. You can rinse it at least 3 times or 5 times with distilled water to remove any residue. For example, if you actually done the first sample collection maybe 1 month ago, and you want to go in for another sample collection, probably this sample container has been there for some time and you have not maybe use it. So you have to try to prepare it again before going out. So this is why you have to use this kind of method. So if distilled water is not available, clean chlorine-free water may be used, which means that this is water which is completely clean, not water which has chlorine inside, so you must use it. And also one other key aspect here is that for any sample which is made for any sample which you want to carry out the microbiological testing, you must sterilize this particular container. That for physical or chemical testing, you don't need to carry out sterilization of this container. So this is the only exception. For physical and chemical water sampling containers, you don't need to sterilize it. It is not a must. So but just make sure you have to maybe carry out some proper cleaning with soap, rinse it properly, with chlorine-free water. And but that of microbiological sampling container, you must sterilize it. So this is the cause of it. So for sterilization purposes, we have the four main types of methods in which we can sterilize our microbiological sampling container. The first one is by using conventional oven, which are going to use this container. For example, you can heat it up. There's a particular oven in the laboratory where you can put it, and you heat it up to at least 180 degrees for 30 minutes. And it's actually a method that WHO has recommended, from the report in 2012. And you also have boiling for 10 minutes in a pot. We call it a water bath. You can boil this your sample container in it to kill all bacteria present in it for 10 minutes. So CDC report on 2010 and WHO report of 2012 says this particular method works best. And also we can autoclave it. An autoclave is also a pressure cooker, it's like putting high pressure on this particular container. You have a box and you can lock it up, and it's going to heat up for about 120 degrees Celsius for 20 minutes. These are all the various ways which you can prepare your microbiological testing containers. So please, I will recommend that okay, so we have here how to label a sample container. So the first step is that before you go to the field, you need to get your sample location.
Yes.
You need to get your sample location.
How many months?
Okay, sorry. Yeah. So please don't turn off your mic or you're distracted somewhere, because you're going to distract me while I'm doing this. Thank you. So the first step is that we have sample location. First, you must know the particular household. Maybe you're collecting a household water sample. Maybe there's a cholera outbreak in the community, and you are working maybe as an eco lab team member in whatever country you find yourself, or something, you're working for a community whatsoever project, and they send you to go and collect a sample. How do you know how to prepare your, to label your sample so that you can actually do a real research work and identify your sample in the laboratory? The first step is the sample location. And you might be in a particular house or maybe a particular water source, because we have different kinds of sampling, which you're going to learn. You can sample water from house, you can sample water from stream, you can sample water source from maybe a well or maybe a hand pump, a tap. So the location is very important. And that is why sometimes you are going to the field, you will need a GPS coordinates also to include in the report, because at the end of the day, if you want to do a kind of water distribution map or maybe a water sampling map, we are going to need these coordinates to be able to map out our zones of work, where we actually collected samples, or we can actually use this map as well as to build a database of the locations that are highly contaminated in our communities. Because once you have the ID, like the geographic location, you can be able to tell and build this map from your results. After the result from the lab, you know that this sample came from this geographic coordinates, and we can use those coordinates now to build a sample location map or a risk analysis location map. So this is just part of it. So that is why labeling sampling container is very important. So the next one is sample distributions. So
I don't know that you want to research today.
Please, I don't want mics on. I don't know who is. So, okay. So the next one is sample description. We have here, you must describe your water source. Is it a spring? Is it a maybe household water storage container? You just have to describe, maybe, is it a well water, or maybe is it a borehole? Just describe it. That's just all about sample description. The next one is ID number. So I'm not going to talk much about this one because during your practice, probably you're going to get to know about it in the workshop, which you'll be doing afterwards. And about ID number is by putting a tag. And in Ecolab, we have a format which we do to collect, to identify our samples. There's having an ID system which we build. So in every ID system, you actually have the name of the project. You have the date, the month of that particular time you're collecting. And then we also have, lastly, the initials of the name of the person. That's the last. That is how we do our sampling ID. And then we also have, in between these parts, we have the type of analysis that needs to be conducted. Also, you have to put in this ID. There's a system, and you're going to learn it in workshop. I won't say that much here. So, okay, we have the other part, which is date and time, which is very important. You can put the date and the time. It's not part of the ID. Maybe it might just help. And then we also have here, okay, I've said about this one, the fit point initial, the person collecting the sample. Yes, so it's all about, you can write your name at this point. And there is a form, you see this form. It's already in the system. I'm going to share this form with you guys. And they'll have other relevant information, project name, like I said, test to be conducted. So these are the 6 main stages or 6 main procedures for you to be able to produce a proper sampling label before collecting your sample. And you have to stick these sample labels on your sample containers before you carry out your water sample, or before you take your water sample, something like that. Okay, so this is the first process here. We have here sampling a surface water. Good. So I'm going to rush now on it. There are some parts which I'm not going to talk much now. So the first thing, the first step, you're going to read the other part of it. So the first step is that you have to remove the cap of the container. This is the first thing. It depends on which type of container, but you have to remove the cap. And when you remove your cap, you don't need to maybe place the lid of your container maybe facing down. You have to open it, like place it open and keep somewhere which is actually safe, which we cannot get any contamination. Or you can give to some other person to hold it. Maybe you have an assistant on the field. You can give that person to hold it. And you should make sure your fingers do not actually enter inside the lid while you're actually removing it. So this is how you have to do it for the first step. The second step now is hold the sample container firmly and dip the open mouth of the container into the water. So this is how you do it. But the third step goes further to describe the fact that it must be 20 centimeters. So when you're collecting water samples from the surface water, for example, a river, a stream, or maybe a standing, whatsoever standing surface water you want to take, make sure that it is 20 centimeters. If you send your hand down deep, make sure you have this container like inside this water in an average height of about 20 centimeters. That is the accurate height which is needed. So you don't need to go right down, because if not, you're going to pick up some sand particles and the rest. So it is not advisable to go down. So this is how we do it for surface water. And also, if you're going to carry out maybe this sampling for a running stream or a river in your community, which is actually flowing, So if you need to do this in a flowing river or stream, you are going to carry out this sample against the direction of flow of the water. So if the water is flowing from left to right, you make sure that you carry your sample, like you're going to send your sample container in the opposite direction, which means that it's going to be from right to left. And probably, I know you're going to ask me some questions after this, why carrying the sample like that. So the fourth step now, we said, leave the sample containers carefully and place on a clean surface and cannot, okay, yeah, probably. And then one of the most important aspects, last thing I'm going to say is that when you carry out your water samples, make sure that you're going to leave a little bit of space. Don't fill it up like to the brim. So keep a little bit of space and that'll be okay for you. So because if you leave it to have a little bit of space, it's going to allow for mixing of your water samples. So it will be proper for transportation. Okay, so this is the example here. You can see direction of flow of water. This is this image. And so we have here, look at this other part, the second image, we have air, we have water, and then we have here, this is the third stage, which go. So sampling an open well or a tank. So I'm going to go fast. So to the image first, let's check it out. So the first one, you see how you're going to do it. The procedures remain the same, like the safety procedures. And like I said, with sampling the surface water. But this is the image which you have to follow up to see how to sample the well water. So the first one shows you how you have to tie a particular rope, and you see how it goes. The second one, you have to put it up, and you see the foot image. So you can see this person sending down, and we have it, the feet and the seat. You take it back up. So this is simply the procedure to do that for a well water in your community, and make sure that you take proper care. And you might have maybe a clean substance as a weight, as a weight, rather than using maybe a stone. Maybe if you use a stone, you're going to add maybe sand particles or maybe some other bacteria around. So you might use a weight, maybe taken from the laboratory, which we actually use a special weight we'll use, and we tie this rope on the container and we send it. So this is just all about for that of well, so sampling tap and hand pump, this is more complicated, and we have to understand that with sampling of tap, you must do 2 steps to understand. The first step is that if there's any attachment in the tap, you have to remove the attachment. Sometimes in our taps, we have some attachment like a pipe, and we have to remove this attachment. And the next step is testing of actual water quality. I want to say that there are 2 types of sampling you can collect from a tap. You can collect a sample which you use to test for the actual water quality from the source. Second, you can collect a water sample from a tap, which you can use to test for the quality of water that the people in that community drink. So the first one, it means that you are going to use, for example, to test for actual water quality from the source, you need to be able to clean up the tap. The opening of the tap, you're going to remove it like you sterilize it, and inside and outside for about 1 minute. And you're going to pour alcohol on the outlet, and then you put a flame. You see the image later on. You put the lighter flame on it, and you have to put this flame for about 1 minute or so. Alcohol, you pour alcohol on the head tap and you flame it. And if you don't have this procedure to do, maybe because there are 2 types of taps, tap maybe head of like we can use. There are some that are made up of plastic, and there are some that are made up of iron. So if you're going to use the method of lighting, make sure that you don't use it when you meet a particular tap which is made up of plastic. Because if you use lighting, to sterilize the head tap, then you are going to cause flames. It's going to actually melt the tap, and you'll be held responsible by the community people. So this is not advisable. When you get to a particular tap to sample and you discover it's made up of plastic, please do not follow the procedure of pouring alcohol on the head tap and then flaming. So you're just going to use your cotton and alcohol and stir it. And actually, the particular percentage of alcohol which you need for sterilization is 30% alcohol. So you need it most often to use. Sometimes you can use, but most standard is 70%, which we use. And we use 70% because it's more common and you can actually dilute if you want, but 70% is the best. So we use 70% alcohol for this sterilization process. So now if you want to test, for example, water which is being consumed by the population, you don't need to sterilize it because at the head tap, many people come around to drink water. Some people maybe are playing with the head tap, and this one, the contamination, everybody just come and carry. And you don't actually want to remove the particular pathogens which are found in the head tap. So you want to actually test what these people are carrying to their homes. So you don't need to sterilize when you go for your sample collection. Just go and put your sample container like you want to carry water to drink the same way, and just open up like any other community persons open without sterilizing. Just open, collect a sample and close, then you take to the lab. So this is most important. So you can see the procedure. We have here the stuff of lightning, and because this second picture shows you where we have here the head tap, and we have a lighter, and actually they have poured alcohol on this cotton or soap, and they have light up flame to sterilize this particular head tap. And we have the other procedure. You see where you're talking about wiping with cotton and then open up and to flow. Also, another thing is that I forgot is that when you are done with the sterilization, you open the tap for about 1 minute, and then you collect your sample. And if you're going to do this for the water, you need to test for the quality based on what the community is actually drinking. You don't need to waste much time. You just need to open up, collect your samples, and see the same procedures here. So we have something, a protected spring. Now for protected spring, some local communities, we have some water sources or catchment which already have maybe an outlet, like a pipe or so. So the procedure is actually the same like that of tap. Just do the same procedure. If you have a catchment in your community that has a pipe outside that's been linked, so people can actually carry water from the catchment area, then you don't need to waste much time. Do the same procedure like that of tap. And if you have an open catchment in our local community where they have not built, sorry, not an open catchment, like an open water source without a catchment. So just follow the same procedures like that of an surface water, like I explained previously. So now, how to sample a household water container. You have every day in your house, you have a bucket, which you guys maybe drink water from it, a drinking bucket, and you need to sample water from it. How do you do it? Presently, to be able to know, the first thing is the first option. If you want to know what particular test to identify if there's a contamination in the water itself, or to know if the people are actually drinking contaminated water, there are two procedures to test. First is to just take the container, if it's a bucket or whatsoever, make sure that you don't take a cup from outside the area, or you take your hand and take your sample container and put inside this bucket. It is wrong. We don't carry out the sample like that. What you need to do is you don't need to put in your hand or dip in your sample container inside the drinking bucket. It is wrong practice. So what you do is that you're going to stand up the bucket, the drinking bucket, and take your sample container and, you know, pour the water into your sample container. And if you need to be able to test for the fact that you want to know if the water this your household consume is actually contaminated from the source, then you are just going to do this particular practice by sterilizing the opening of the container. If you have maybe something like a gallon, if you have a gallon like the one we have, 20 liters, and you just need to sterilize the opening, and then you pour the water inside. This is how you're going to do, and pour it inside your sample container. But this is pretty much the system. So to know actual quality, the actual quality of water which the people are drinking, you don't need any sterilization. And secondly, if you need to know if the water quality, if you need to know the water quality from the source, not the one the people are drinking, then you are going to sterilize the opening. This is just a simple trick. So you know that you're having this, and it is clear that this sample is for determination of truly if the water these people are carrying is contaminated from the source. And second sample is to test if the people are having this particular water in the house and it's contaminated, and they are drinking this particular water, it's already contaminated because they are the ones that have been using this container. That is, they have contaminated the particular water. So this is just about everything you need to know about this practice. And we also have here how to transport a water sample. So in this aspect, we are going to understand that to be able to transport our water samples, we must have a particular equipment, which is like a cooler, a flask that we have an ice inside. So with this cooler, you'll be able to use your sample containers and put inside. So we have to have a particular temperature to be able to preserve our sample before we are taking it to the laboratory. And this temperature must be at least lower than 10 degrees. So most of the times, this cooler must have a temperature of 4 degrees. Why? Because at higher temperatures, some of the bacteria, by the time you collected this water sample and you don't put in this kind of cool environment, those bacteria that are there will die off, obviously. So when you're going to the lab to test, you are not going to be having the actual contamination value. So this is why you need to preserve the water, because at cold temperatures, this bacteria will still live at that particular temperature. That is why you need to have this cooler. And also, you must also understand that for you to be able to carry out your water test, immediately you take your sample, there are some tests which is most important to do. The pH, the turbidity, and chlorine, residual chlorine in the water. So you must be able to do this test immediately on the field before you're taking this sample to the lab for further testing. And also, if you have stayed for more than 24 hours, like one day, that you collected the particular sample, then that sample is regarded as a waste. So you don't need to run any test with that sample. If you did not run a test within 6 hours after collecting this sample, then you cannot further continue with your sample. So you have to throw off the sample and go back to the field. This is just a procedure you need to understand. Okay. So finally, questions and answers. And we try to rush a lot. So any questions? There's not 1 minute here. Is there any question? Mhm. Nice, nice, nice.
Hello, sir. I have a question.
Yeah, so can you say it fast? I think.
Okay. I just wanted to ask, is there like a number of hours that the sample water needs to remain in the container before it tagged as valid or